Hello everyone, my name is Mahmoud. I'm the engineering manager for the Visual C++ Libraries team. Today I'm going to talk about the progress we have made in completing the Visual C++ implementation of the C++20 standard. Last year, also during the Pure Virtual C++ conference, I gave an update about C++20. I talked about migrating STL development to open source on GitHub. Also presented a summary and demonstrated some of the C++20 features that were implemented by the STL contributors. At that time, approximately 30% of the features were yet to be implemented. And the demos and any other C++ projects targeting C++20 were all built using the stud C++ latest switch. That switch is normally used to preview C++20 features. Today, I'm happy to announce that MSVC's C++20 is feature complete. VS 2019 Update 16.10 Preview 2 have shipped already mid-April. That preview included all the remaining C++20 language features, as well as a majority of the standard library features for C++20. For the first time, we have included the stud C++20 switch. What that means is that MSVC C++20 implementation has now graduated. Developers can start porting their project to C++20 right away. However, there are still a couple of library features that are not yet included with Visual Studio. Specifically, those are stud chrono and stud format. Those features have already been implemented on GitHub, on github.com/microsoft/stl. And they will be included in the next preview of Visual Studio, which is going to be 16.10 Preview 3. Also, I would like to highlight a new compiler switch, await strict. That switch enables the use of coroutines under legacy C++, C++14 and 17. We did that because coroutines is one of the most popular C++20 features. And we wanted to make sure it's also available to code bases that cannot quickly migrate to C++20. In this chart, I show the timeline for implementing the C++20 libraries feature for Visual C++. Starting from day 0, around 3 years ago, actually more like 3.5 years ago, we started the development process for C++20, specifically the library features. Each time the line goes up, that means new features have been voted into the standard. Each time they go down, here for example, that means we have, sorry about that, that means feature has been reviewed and implemented. It's worth noting that the library feature implementation was just completed a few days ago, which gave me an opportunity to announce it today. So we actually drove back to 0 around April 22nd. We drove to 0 on April 22nd. Before proceeding further, I would like to thank the STL GitHub community for their awesome contributions and for getting C++20's STL's implementation to the finish line. Thank you all. Now let's talk a little bit about the features, specifically the library features that have been implemented in 16.10. This table shows all the C++20 library features shipping in the various previews of VS 2019 16.10 update. As I've already mentioned, there are still 2 features, stood chrono, and stood format that are yet to be implemented. They have actually been completed on GitHub, but never shipped with any Visual Studio yet. They will be included, they should be included in the next 16.10 preview. Fingers crossed, of course. The table also shows contributors to each of the features. Some of the features had as many as 10 contributors. For example, for Chrono, Spaceship Operator, and other features actually not shown here in this table. That shows the amount of effort and collaboration that went into creating this. While this table is only for features shipping in 16.10, the changelog on GitHub contains the full list since 16.5. So, the changelog documents the features and bug fixes included with every preview and every GA general availability release of Visual Studio 2019, plus all the corresponding pull requests and other important information if you're interested in finding out how and when each of those were implemented. We plan to continue reusing the same page, the same changelog page for future C++ standards implementation. For example, C++ 23, and for all future bug fixes too. That touches the standard C++ library. So, if you want to know if your favorite feature will ship soon or if that annoying STL bug has been fixed or not yet, then that page is for you to visit. Now, let me quickly demonstrate some of the C++ 20 features that have been recently implemented. I will talk about both language and library features. Also, I will demo some sample code using Visual Studio 2019 16.10 Preview 2, which is the latest preview that is publicly available now. Ranges. No discussion about C++ 20 is complete without bringing up ranges. Ranges is a huge feature. It's the largest in C++ 20, I believe, or any even C++ standards to date. As the name implies, it provides new components and features to manage sequences or ranges of elements. The ranges implementation was just completed in 16.10 Preview 2. It has been contributed by various developers, Ahana, Casey, Armin, and Michaels. Again, Michael, thanks you all. Casey is also the co-author of the WG21 proposal for ranges. One important thing to note about ranges is that it is based on concepts. Concepts is another major addition to C++ 20. If you want to know more about it, then please read the blog that Shangfan has written. This one here. And it included detailed information about the feature. You can go visit that link to know more about it. Also, make sure to read another blog post that Casey wrote around 16.6 timeframe about the initial ranges supporting Visual C++. Hopefully, we'll get another blog post from Casey soon after 16.10 Preview 2 ships, 16.10 Preview 3. Now, let's get to the demo. So in this demo, I've divided the demo into 4 different files. Each one demonstrates is invoked by a function, one of these functions, and demonstrate one of the features for that I'm going to talk about today. Starting with ranges. So the first thing I'd like to do is make sure I'm building for the right Visual Studio. I'm targeting the right Visual Studio version, C++ version. So I'm going to C++ language and making sure. So previously I've been using the preview to C++ latest. However, because now C++ 20 is supported, I'm going to switch to that. The ranges demo is divided into two different sections, one talking about algorithms, the other talking about view adapters. I'm not going to go deep into the details about each, but I'd like to show you that, like some of the important features that ranges provide. One of them is algorithms. Here I'm showing two different types of algorithms, actually three: copy ranges copy, stood ranges copy, and stood ranges find and find if. Okay. So actually I remove the find if, so just stood ranges copy and stood ranges find. So in copy, as you would expect, I've actually demonstrated demoed the same last year as well. So if you've seen it, it's just the same one. And here, copy, it just copies from one range to another, or one sequence to another. And copy if will do the same, but it will pass through a function that will filter out, filter in actually elements that it needs to copy. Find is just the same. It has additional filters. For example, here, get first, which means it will get the first element in a pair. Get second means it will compare the second element in the pair. So this is a comparator that find uses. So let's quickly run both of these examples. I'm gonna comment out the adapters demo and let's build it. See what happens here. By the way, if you're building the demo, make sure you're using Visual Studio 2019 Preview 2, 16.10 Preview 2. You can do that by using help about Microsoft Visual Studio and making sure that you're actually using this version, or later, of course. Now let's try this. So as expected, the demo here copies everything. The copy demo. It copies everything to the list to the output. And copy of mod 3 covers everything that's divisible by 3. The find, it start trying to find everything that starts with 70, any pairs that start with 73, none found in the list, or ends with 23. We have two pairs that ends, sorry, one pair that ends in 23, 0, 23. Let's try the other demo, which is probably the more interesting one, which is the views and adapters demo. One of the powerful, why ranges is very powerful is because it provides you with adapters and views that can do a ton of things and can greatly reduce the amount of programming or manual, your own algorithms that you need to write. I've just demoed a couple of them here. However, there are a lot more. So here I'm demoing or demonstrating how to use a split view, the ranges view split, which what it does, it takes a range and divides it into sub-ranges based on a delimiter. So in this case, I'm taking a string and I'm splitting it based on spaces. So here space, space, space. And I am gonna print it out using this function here. Similarly, in the join, I'm gonna use another ranges view, which is join, and I'm gonna the code here is gonna append them together. So let's try those two. Okay. So actually, yeah, I forgot about the counted as well, which is here. I'll talk about it after here after this is done. So here's a split demo. It splits into different subranges, printing each one. The join just joins the subparts of this URL. The counted here, which I forgot to talk about, presents a view of elements in the range of I to n. And I can basically create a subrange out of this. So in this case, for example, I start from the beginning of the list plus 2. So I start at 3 and count to 5. So 3, 4, 5, 6, and 7 should be included. Let's run it and see. Yep, 3, 4, 5, 6, and 7. Okay. 6. Now let's go back to the slides. Another very useful feature of C++20 is the Spaceship Operator, or the three-way comparison operator. For those of you who haven't used it yet or haven't heard of it yet, it's a new C++20 operator that compares two values and determines if the left-hand side is less than, greater than, or equal to the right-hand side, all in one operator. It's used in other programming languages, but the first time to be adopted in C++20. There are several language and library proposals that capture the work needed to support Spaceship Operator, okay, including the adding Spaceship Operator library and the Spaceship Operator in implementation, as well as library support for Spaceship Operator. All of those have been implemented. Some of those are libraries, others are language or compiler features, and all of those have been implemented by MSVC. The one I'm going to demo today is P1614, which calls for supporting the Spaceship Operator in the library types, such as containers, strings, and ranges. Adding the three-way comparison operators, the Spaceship Operator, the library types, has been another very large C++20 feature that has just been recently completed in 16.10 per v2, with many contributors over the last year. Thanks to Adam, Ahana, Anju, Casey, Curtis, Daniel, Michael, Statement, Reply, Stefan, and Superwig, all of which have contributed to this amazing feature. Let's do a quick demo. This is going to be a straightforward, simple demo. First, I'm going to demonstrate how to use a Spaceship Operator in a vector and then in a string. A lot of other types are supported. All the ordered and non-ordered types are supported. Container types are supported, and other algorithms and numerics are also supported as well. But I've chosen to bring it as a proof of concept for what has been completed so far, or actually the works that have been completed in C++20. Here I'm creating three different vectors. A1 and A2 are similar, so they should be equal. B1 is different. It has more elements, but start with it contains a different value it's filled with different values. So, as expected, If are A1 and A2 equal? Yep, they should be equal. So the spatial operator here should return 0. Or is A1 and B1 equal? No, they're not. So the expectation here is that it will return less than 0. So both of these should return true. Are B1 and A1 is not equal to 0? Yep. So this is very similar actually to the previous one, but this one should return false instead. The next three are comparing using the spatial operator for comparison using the iterators themselves. So I'm going to comment out this section for strings and run it. Okay, so as expected, true, true, false for these three comparisons, true, true, false for the next three comparisons. Okay. Now let's try the strings. Strings should also be straightforward. S1 and S2 should be the same. S1 and S2 are smaller than S3, but bigger than S4. They're also smaller than S5, but bigger than S6. So I'm going to leave it to you as an exercise to make sure that these are all true. But basically, we compare against internal types, strong ordering type. Equivalent means equal, less, greater, and less, greater. So all of these should actually return true. Let's try it. Yep. All the string operator, spatial operator comparison for those string demos return true here. Okay, let's return to the slides. The next feature is, unlike the previous two, is not a library feature. It's actually a compiler or language feature. Const init and its sibling const eval are language feature, i.e. they are implemented purely in the compiler. Both of them are new specifier, new keywords in C++20. A variable declared with const init means that it should have both zero initialization and constant initialization. As for const eval specifies that a function is an immediate function. What's an immediate function? It means that every call to that function produces a compile time constant. Yeah. Let's have a quick demo. Okay. Like the other demos, I'm dividing it into two. So let me start with the const eval demo. Const eval or immediate functions demo. Basically, a function created with const eval must return, every call to this function must return a compile time constant. So let's look at the first one. Will this one return my const value, return a compile? Yes, because every time it's always going to be returned 10 times 1. It can be evaluated compile time. Similarly, if I is const, it will return a constant value. This one is also still okay. A const function being utilized by a const eval function is going to return 1. However, the third one here will return an error. If I try to use a non-const value, this for example J3, then this one will fail to compile. Let's try to compile first without that. So now it built successfully. What if I do this? Let's see. Of course, I need to also to. So the call to immediate function is not a constant expression. So this one fails. Let's comment it out and try to run it here. Okay. So the demo here, we call the function 3 times. First time was 1 times 10 is 10, 2 times 10 is 20, and then we call it again with I, which is 10 times, which is 20 times 10, that's 200. Okay. Let's try the other demo, the const init one. So const init implies that a variable declared with the const init specifier has both zero initialization and constant initialization. That includes thread specific and global and static variables. All of these are thread local storage and static variables. All of these can have the global or constant modifier applied to it. So first one here, these examples are directly from the demo. Directly from the proposal. So this function here is create constant. Sorry, it's not very clear here. So this one basically calls into f, which compares, takes a boolean. If the boolean is true, it will call a function that's a const. Otherwise, it will a function here. Otherwise, it will return a constant value. If it's true, it will return constant. Otherwise, calls a function. Okay. Now let's build it and see what happens here. Okay. If I try, so it built successfully. If I try to build it with rather than true with false, meaning it will call g, then this will not evaluate to a constant. It won't be an immediate function. It won't evaluate to a constant value. So compile time constant time. So let's see what happens. Okay, so this is a non-constant expression, so it fails. All globals have static storage duration, so they can be declared with constant. Now let's see what the demo does here. So first we call the constant function, we try to return, run the function and get the value here. So this should print constant initializer. This one should print the value global constant int value, which should be 0 because it's 0 initialized. Let's try it. Yeah, so constant initializer, 0 constant initializer for this one here. Sorry, maybe make it clearer here. Here, because I'm using static, then I can use the constant here. Similarly, this value, the int here is declared to static value, so I can use a constant. However, if I try it with something local, like this one, for example, then this will not be, that variable declaration cannot be used because it doesn't have static or thread local storage duration. Similarly, this will fail for the same reason. Okay, because I'm using true, so it will call into a dynamically initialized function. Okay. The next demo I would like to show is about standard library header unit support in C++20. Standard library header units enables the modular use of the C++ standard library via header units. It guarantees that standard library headers such as vector, string, or algorithm can be imported as header units in your project. This is largely a compiler feature based on C++20 modules. Stefan, most of you know SL already. SL has validated and in some cases refactored the C++ standard headers so they can be imported as header units. The walkthrough linked here provides a great overview of the feature and a very good practical guide on how to enable it in your project. Let's jump into this demo. This should be a quick one. So first, let's build it. What this demo does, it has some code that makes use of those headers here, and it doesn't do much. Just prints hello C++20 and adds a few numbers here, making use of some algorithms, some containers such as vectors, strings, and stream functionality. Now, instead of using the include, I'd like to use the shiny new keywords import to use them as modules or header units. So let's try to build it. Okay, something happened here. It could not find the header units for each of those. So normally what you need to do in order for this to succeed, if you're not running a Visual Studio, you will need to build those header units yourself. So, however, if you're running it in Visual Studio, you can simply go to properties here, go to General, and update this from no, scan sources for module dependencies from no to yes. Normally, you don't want that to be enabled in your big projects because it can take a very long time, and only when you need it. Okay, so there's a lot more discussion about it in the slides here in the walkthrough. So if you want to know more about why we do that and how is that project system option, why is it enabled, and then you can read through the walkthrough. Now let's try to build it here. Okay. So as you can see, it's actually compiling those header units, algorithm, IOC, vector, and string. Let's try to run it. Awesome. It did the same thing exactly. Okay. So this was the last demo of the day. Thanks for watching so far. Finally, we've reached the end of the talk. Now I have an ask for you. Please try out the new C++20 features that are available in 16.10 Preview 2 and later. Preview 3 will be released soon and will have a full support for C++20. All the language and library features will be included. The IDE will also include, such as IntelliSense, will also support C++20 features as well as the project system, as we have seen with header units, for example. Do turn on the stood C++20 switch for your existing project and send us your feedback. If you have compiler, project system, IDE, or IntelliSense issues, please submit a feedback ticket using the developer community portal here. However, for any library issues, please submit them directly through the SL GitHub repo. Thank you all, and bye for now.